Okay, to finish up our review for data analysis, the second worst collapse in Atlanta in 2017 was the bridge over I-85. The biggest collapse that year happened in Houston at the Super Bowl. So for the Falcons, this was the offensive scoring totals of the team that year. Create a box plot and give the values of the minimum, Q1, medium, Q3, and the maximum. So in order to do that, I've already entered my data. So if I come over here, I think I've entered the data as um, Falcons. So I've entered that. So I just need to create a new data and statistics. And I'm going to put the Falcons data right there. And menu, plot type, that will be a box plot. So in a box plot, I will find the minimum right here at 15. So the minimum is 15. If I come back over here and I see Q1 is 28, so 28. The median is this line right here in the middle, that's 35. Q3, that quartile is 42. And then the maximum is right here at 48. So that's the 5-number summary. So sometimes you'll see that it's the 5-number summary for that data set. Okay. In the top 25% highest scoring games, so if I look at my box plot, the top 25% corresponds to right here at the edge of this box from 42 to 48. So in their top 25% highest scoring games, they score between 42 and 48. So remember, this divides your data set into quartiles. So this is, from the minimum to Q1, it tells you that that's the first 25% of your data set. That's the next 25%. That's the next 25. And this is the remaining 25. So the top 25% of my games, I score between 42 and 48. Okay. Next question. Kids from last year hated this, but anyway, I will subject it to you in a review. They didn't see it in a review. They saw it on their tests. So it's just a concept that talks about correlation. Remember on the SAT and PSAT, they're not going to ask you to calculate the correlation. They're going to ask you to interpret something about it. So you've been told by one of your parents that this scatter plot and the coefficient of correlation indicates this is not modeled well by a linear line of best fit. You can see that your parents are probably right on this because there's no line that really fits this data set. But your parents tell you to put your cell phone away and think about breaking this into 2 data sets. You decide to take your parents' advice on both accounts. Can you see a way to model this data set linearly if you split it into 2 separate data sets? Draw your modeled lines of best fit and discuss. Would one part of the model have a stronger correlation than the other? What are your best guesses for coefficient of correlation for the 2 data set, and what reasoning backs up your guesses? So it's pretty obvious if you look at this. If I were to sort of split this data set in 2, it looks like, I could model this one with a line that looks like this, and maybe not as well, but, perhaps I could model the other data set with a line that, maybe looks something like that, okay? So it tells me if this is, we'll just call this part A and part B. You don't have to do that, but just for labeling purposes, which of those is better? So it looks like, obviously, we have better correlation. So we have better correlation in part A. We have weaker correlation in part B. So better or stronger, okay? So I'm just understanding, do you know the concept of correlation? Which would be stronger? We've established that part A would have a stronger correlation than B. What are my guesses for the coefficient of correlation? Here, there's no exactness. Don't worry about the number, but if you look at correlation in A, that's going to be a negative number. So I'm going to go with maybe negative 0.8. You might say negative 0.7 or negative 0.9, but anyway, it's a negative number. And then if I go to part B, that's going to be a positive correlation. But whatever I pick for A is going to have to be weaker, So I might say that, it's positive, zero point 0.4. Don't worry about those numbers. I didn't count off for like the numbers being wrong, but the concept was for part A, you've got a negative number. For part B, you've got a positive number. And for part A, that number is closer to 1 than part B. So you understand relatively what correlation means. Part A would have a negative correlation, part B would have a positive, but A would be stronger, closer to -1 than B is. B would be further away from 1 or -1 in that case. So that's really all that is. And I think once you see it, it makes sense, but being thrown something like that on the test might have thrown you for a loop. But that's the kind of thing we're after. Do you understand what correlation is and how to reason it in terms of a problem? So that's it for the review.